8.6, further graphing of quadratic functions. So more ways to graph quadratics. So write quadratic functions of the form y equals a plus x minus h squared plus k. So we know that the graph of the quadratic function is a parabola, which is the U shape, happy face, sad face. So if the quadratic is written in vertex form, then we can find the vertex h and k and graph the parabola. That's what we're doing in 8.5. So now we're going to learn how to graph quadratics in standard form, which is ax squared plus bx plus c. So to find the vertex, we use something called the vertex formula, and it's x equals negative b over 2a. Once you get x, plug it back into the quadratic equation to solve for y. And that's how we find the vertex, because remember, the vertex is an x and y point. So once you get x, you have to plug it in to get y. Your axis of symmetry is the dotted line that cuts the parabola in half, and that's just the x of the vertex. Intercepts. X-intercept, you make y equals 0, then solve. Y-intercept, you make x equals 0, then solve. But I'm going to teach you a trick for the y-intercept for the quadratics. All right, so we're going to graph using vertex, axis, and any intercepts. And this is my preferred way of graphing because I don't know, it makes more sense to me. I'm not a transformations person. I'll use them when they're applicable and sometimes better. But for the most part, I just like to do the work and put in the work and not have to memorize rules. And that's the thing with transformations. You have to remember that, oh, if it's left, if it's negative, I have to go right. If it's positive, I have to go left and all that stuff. So the first thing we're going to do is find the vertex. So remember the vertex, that's x and y. So to find x, we use the vertex formula, which is negative b over 2a. So a, b, c, just like the quadratic formula. So let's plug it in. We have negative b, which is 6, over 2 times a, which is negative 3. So negative 6 over negative 6, we get positive 1. But don't forget, we need x and y. So we need to plug it back into the quadratic that they gave us. So when we plug it back in, we have y equals negative 3 times 1 squared plus 6 times 1 plus 4. And all we do is simplify. So 1 squared is 1. 1 times negative 3 is negative 3. 6 times 1 is 6 plus 4. And that leaves us with 7. So our vertex is 1, 7. That means we also have our axis of symmetry. Our axis of symmetry is just the x of the vertex, so x equals 1. Now all we need to do are find intercepts. So we always have two types of intercept, the x-intercept and the y. Let's do the x-intercept and then I'll teach you a trick for the y. So for the x-intercept, we make y equals 0 in our quadratic. So we have 0 equals negative 3x squared plus 6x plus 4. All right, so to find the x-intercept, we make x equals 0. Now, there are a few ways that we can solve this. We can factor it, but this is not factorable. We can use the quadratic formula, which for this is just a pain. Or we can use vertex form. So remember, vertex form, that is f of x equals a times x minus h squared plus k. And isn't that the vertex? And don't we have that vertex. We found it. Remember the first part, we found the vertex? It was 1, 7. So I know I can put those there. Now, a is your growth factor. That's actually what it's called. And it's that number in front of x squared. Because isn't this a, b, and c? A stands for a. Like, doesn't matter what it looks like. If it's a, it stands for a. So we have h, we have k, and we have a. It's negative 3. We also have one more variable. Now we can plug it in and solve for x. But we do have one more variable. You might not see it. We actually have f of x because it's 0. So we have y, which is 0. So let's plug everything in. We have 0 equals a, which is negative 3, times x minus h squared, so minus 1 squared, plus k, so plus 7. This is much easier to solve than using the quadratic formula, because all I have to do is subtract 7 to both sides. So we have negative 7 equals negative 3 times x minus 1 squared. Go ahead and divide by negative 3. So we're left with 7 over 3 equals x minus 1 squared. Now we can take the square root of both sides. So when we do, I'm going to bring it up here. We have square root of 7 over square root of 3. And don't forget it's positive negative. And that equals x minus 1. So we have two equations. We have square root of 7 over 3 equals x minus 1. And we have negative square root of 7 over square root of 3 equals x minus 1. So let's add the 1 over. So now we have 1 plus square root of 7 over square root of 3. And then we have, so add 1 over. We have 1 minus square root of 7 over square root of 3. We have to rationalize our denominators, so times square root of 3 times square root of 3. And we get 1 plus square root of 21 over 3. And then we get 1 minus, so times square root of 3 times square root of 3, square root of 21 over 3. These are exact solutions. That means our x-intercepts are 1 plus square root of 21 over 3, 0, and 1 minus square root of 21 over 3, 0. Now, we cannot graph those, so plug it into your calculator. So 1 plus the square root of 21 over 3, we get 2.70, and 1 minus the square root of 21 over 3, we get negative 0.70. So that's what we're going to graph as our x-intercepts. Now, it won't always be that difficult. I made it difficult, so I will show you what's the worst I can throw at you. Now, to find the y-intercept, yeah, that was just the x-intercept. The y-intercept is c. It's always 0, c. So the y-intercept is 0, 4. That's the trick, I know. It's so nice. All right, so let's plot our vertex at 1, 7. Then we have our axis of symmetry. Now we're going to plot our intercepts. So we have an intercept at 0, 4. And then we have two intercepts at 2.70. That's almost 3. And then we have another intercept at negative 0.70. So that's about almost 1. And now we connect the dots. So the yellow point here, you see how it's 1 away? So in the other direction, we also have a point there, because the axis of symmetry tells me that. All right, the next example, it's much easier. So you can factor, to find the x-intercept, factor the trinomial. Everything else, though, you'll be able to do. So I want you to go ahead and pause the video and try the next example. All right, I hope you tried it. So the first thing we do is find the vertex. So we use the vertex formula, which is x equals negative b over 2a. So we have negative 4 over 2 times 1. So that's 4 over 2, which is 2. Now we need to plug it back in to find y. So we have y equals 2 squared minus 4 times 2 minus 12. So 2 squared is 4. Negative 4 times 2 is negative 8 minus 12. And we get negative 16. So that means our vertex is 2, negative 16. And that means we have our axis of symmetry, which is x equals 2. All right, now that we found that, we can find our intercepts. So x-intercept, you are able to factor here. So we make y equals 0. So we have 0 equals x squared minus 4x minus 12. We can factor this down into x minus 6, x plus 2. So we set each of these equal to 0 and solve for x. So we add 6 to both sides to get 6 equals x, subtract 2 to both sides, so we get negative 2 equals x. That means we have two intercepts at 6, 0 and negative 2, 0. Remember, our y-intercept, there's really no looking for it. It's just c. So that's our y-intercept. So our y-intercept is 0, negative 12. If there is no c, it's 0, because 0 means nothing. All right, we have everything we need to plot. See how much easier that one was? Right? It's because we could factor. Right? That was just, whew, we got this. A breeze compared. All right, so let's plot our points. We have 2, negative 16, so I'll say that's all the way down here. We have our axis of symmetry, our y-intercept of 0, negative 12. So we'll say it's just here. Negative 12 is about there. Then we have our x-intercept of 6, 0. And negative 2, 0. And as best as you can, connect those dots. So on the homework, they're actually going to have you put this into vertex form. So vertex form is f of x equals a times x minus h squared plus k. So remember, x and or h and k, that's just the vertex. So h is 2, k is negative 16. Your a is your growth factor. So a is literally a. Since there is no a, it's 1. And that's all we need to plug in. So we have f of x equals a, which is 1. You never need to put 1. So x minus 2 squared minus 16. That would be the vertex form. All right, I kind of talked about minimum and maximum in the previous video. So the quadratic function whose graph is a parabola that opens upward has a minimum value, and the quadratic function whose graph is a parabola that opens downward has a maximum value. So if it opens up, it's maximum. If it opens down, it's minimum. So the Utah Ski Club sells calendars to raise money. The profit P in cents from selling X calendars is given by the equation P of X equals 360X minus X squared. What is the maximum profit the club will earn? Now let's rewrite this in standard form. So that would be P of X equals negative X squared plus 360X. If it's money, A is always negative. You'll learn why in college algebra. All right, so we want to look for a few things. We have a quadratic because it's squared, so we know we have a quadratic. And then since we know we have a quadratic and we have the word maximum, that means vertex. And since it's maximum and it opens down, it means this. So the vertex, that's x and y. But in this formula, in this problem, they're not using x and y. They're using x and p. Because x, that's what's the variables given, and then that's p. So if we want to find the maximum profit, we're looking for the p of the vertex, also known as the y of the vertex. So that's what we're trying to find. So first we have to find our x of the vertex. So x equals negative b over 2a. So x equals negative 360 over 2 times negative 1. So we have negative 360 over negative 2. So negative 360 divided by negative 2, we get 180. So now we have to plug that back in to find the profit. So we have profit equals negative 180 squared plus 360 times x, which is 180. So we have profit equals negative. So 180 squared is 32,400. 360 times 180 is 64,800. And we simplify to get 32,400. And remember, that's in cents. That's in cents. So we need to convert 32,400 cents to dollars. Because, like, can you picture 32,400 cents? I can't. That'd be cool. I'd like to see it. Like, like Scrooge McDuck's bank, But I have no idea what that means to me. So we're going to switch this over. So we know that there is 100 cents to a dollar. So all we're just going to do is divide by 100. So we have 32,400 cents. And then that goes into how many 100 cents? Because how many 100 cents, that's the dollar. So we can cancel out zeros, which makes our life easier. So we get $324, which makes sense to me. So what we just found was the 180, that we found. The 180 stands for the max calendars sold. That's what we just found. And that's what X represented. X represented calendars sold. Then the Y that we found, the Y value that we found, which actually stood for profit, was $324. So what that means is that's the most they can make. Now, how can you know that? How can you determine how much money you can and cannot make? Well, that you'll learn in business calc if you're going to go that far. But if we try to generalize the explanation, it's supply and demand, meaning we know how much people are willing to buy and how much they're willing to buy it for based on patterns, human consumption, consumerism, things like that. We study this. So we know how much typically we're going to sell. We go off of data. So we go off old habits or polls and stuff like that. And then what they do, so a statistician, they'll hire a person to ask questions or gather research, or they'll do it themselves. Then what they'll do is they'll crunch the numbers, all the data, they'll crunch the numbers, and then they'll spit out equations. So the 360x minus x squared, that's what they'll give us. Then what we can do from there, well, a statistician can do this too. What they'll do, and you will see this in stats if you're going to take stats and business calc. What they'll do from there is find the vertex like we did and say, at most, you're going to sell 180 calendars and you'll make $324. And that's at most. So that's like that's on a good day. That's how much you're going to sell. And you see how much that revolves around business and how this is how you run a business. Quadratics rule money. They do. Everything, retirement, how we determine stocks, how we determine how much people are going to buy and sell for. It's 90% of it is quadratics. So they're super important to fully understand. All right. Now, money is something we really do understand. We have a great grasp on money. We know it well because it's tangible. We've all worked with it. But what about a projectile? Now, same exact example. It is. And when you take it down and strip it down, it's the same concept. But how do we arrive at that concept when we're given something we really can't hold on to tangibly? We can't really see that in ourselves or work with it ourselves. So if a projectile is fired straight upward from the ground with an initial speed of 256 feet per second, then its height h in feet after t seconds is given by the function h of t equals negative 16t squared plus 256t. Find the maximum height of the projectile. It's supposed to say projectile. You know I can't type. When will the projectile strike the ground? So that's something that is a lot less meaningful to us. We have to use our imagination. We have to really think hard on what that looks like. So what I like to do is this, if I can, I like to draw pictures, because then when I draw a picture, I can kind of start to understand it for myself. So we have a projectile being fired straight up. So a projectile to me, I like to say rockets. I mean, rockets are pretty darn cool. And we live in Florida, so we get to see rockets blast off. How freaking... That I will never get over, guys. You have no idea how cool that is. In California, they used to land there. So I used to see them land, like every few years I would see it. It was pretty cool. All right, so we have our rocket. I'm not the best at drawing. And we're going to fire it up, all the way up. I'm going to go past the letters. And then we want to know, when will the projectile strike the ground? So here we have the ground. What we're looking for is this point right there. That's what we're trying to find. When will it strike the ground? When. That's a really key word, because doesn't when I say when is this happening, or when should I come over, or when are we doing this, or when, isn't that always about time? So come over at 2, leave in 3 hours. That's when. So if we trace back, we want to find the maximum height of the projectile. And then, when will the projectile strike the ground? All right, let's keep going back. We have a quadratic. How do we know we have a quadratic? It's squared. So we know we have a quadratic, and we have the word maximum. So we know vertex, which is x and y. But instead of x and y, it's not x and y in this example. It's t and h. So instead, we're going to use t and h. All right, so that's all the information we need. Everything else we don't really care about. It's just telling us about how fast it's going and where it's getting sent to, or how it's being sent. All we care about is that we have a function or an equation, and then what it's asking us. All right, if we're trying to find the maximum height, that represents h of the vertex, because h is height. So we need to find the y of the vertex. There's no going around it. You need to find x before you find y. So let's go ahead and find the x of the vertex. So we have x equals negative b over 2a. So looking at our function, we have negative b, which is 256, over a, so 2 times negative 16. We're going to simplify here. So we have negative 256 over negative 32, and when we simplify that, we get 8, positive 8. So that's what x is. X is 8. Now, to find the y of the vertex, or in this case, the h of the vertex, we're going to plug it in. So to find h, we're going to plug it into the quadratic that they gave us. So we have negative 16t squared plus 256t, and the t is 8. So let's simplify. We have negative 16 times 8 squared, which is 64, plus 256 times 8, which is 2040. Keep simplifying. Negative 16 times 64 is negative 1024 plus 2040, and 48. 2048. We combine like terms to get h equals 10,000, or keep wanting to say 10,000, 1,024. So we know the maximum height. So the maximum height is 10,024. I keep saying it, 1,024. Gosh. And then we have to see if it's feet or meters or whatever. It's feet. So the maximum height of this projectile is 1,024 feet. Awesome. So just kind of extra information, you know the 8 we found? That means it will reach maximum height after 8 seconds. So after it fires in 8 seconds, it will be 1,024 feet, and then it'll start to go down. So what that looks like, I'll kind of draw it. So this is the vertex right there, which we know is 8, 10, 24. So that means it fires up, and 8 seconds now have gone by. And at that 8 seconds, we're at 1,024 feet. After that, it's going to start to go back down. That's what we just found. All right. Now it's asking us, when will the projectile strike the ground? So when represents t. I'm just going to rewrite our function here. We have h of t equals negative 16t squared plus 256t. So we drew our little picture, and when is when it strikes the ground. So left and right, doesn't that mean x? So, or in this case, t. Okay. And ground, when will it hit the ground? Ground, isn't that height if you're talking about the ground? So height is 0 when you're talking about the ground. So we're given h of 0, we're trying to find t. We're trying to find when will this happen. Ground, striking the ground, striking the water, striking the pavement, striking the floor, height is 0. That's it. We don't care about sea level there. We're just saying height is 0. All right, so let's replace it. We have 0 equals negative 16t squared plus 256t. Now, this is a binomial, so when it's a binomial, we look for a greatest common factor, and they have one. The greatest common factor is negative 16. So we're left with, 16t. So we're left with t plus 16, minus. Now that we factored, we separate them, so we have 0, 0 equals negative 16t. So divide by negative 16, and we get 0 equals t. So that means nothing to us. I don't care about that. And then we have 0 equals t minus 16. So add 16. We get 16 equals t. So 16 seconds it'll hit the ground. So after it fires off, after 16 seconds, it's going to hit the ground.